sort of motivated me. Fine. I also knew that anyway, perhaps it's a new area we're looking at. Okay. But you are to draw a velocity time graph for a body that is thrown vertically upwards. Let's even do it for thrown vertically upwards and then downwards. So if an object is thrown from a height, maybe the top of a tower, this is the tower. A tower will certainly be erected on the ground. So this is the ground. So this, we have the tower here. When an object is dropped from the top of the tower, they be thrown to come down in this manner. Its path, which is also known as a trajectory. Isaac, mute yourself for me. Its path will certainly be coming down. And here, when it hits on the floor, it can't go up again. But the velocity time graph, this is the path or trajectory. Trajectory. Now the velocity time graph, V against T. When a body is falling up, down, it is free falling. Here, gravity in the absence of air resistance. And in our case, we are looking at air resistance being neglected. Okay, so the object would fall freely, meaning that the initial velocity is 0. So for free falling, the initial velocity u is 0. If initial velocity is 0, as the body falls to the ground, class, what happens? Assuming this is the ground, as the body falls to the ground, what happens to the velocity? Yes, a quick response for any one of you.
Increases.
Its speed or velocity increases. So when we are plotting the velocity time graph, we must start from a point where its velocity is 0. And as time increases, because its velocity will be increasing, we'll have a straight line graph like this. So for free falling bodies, this is the velocity time graph. Now the displacement time graph. The displacement time graph for a body falling in this manner or free falling is this. This also indicates that its displacement would also increase with time. As the body falls, it will be if the initial point is where the body starts dropping, and we are considering downward motion as positive, then as time goes on, you realize that the body's displacement would increase. But it's a curve because of this formula to determine it. Because u is equal to 0, h will be equal to half j_t squared. Of if you are using the increasing speed, then h will be equal to v squared over 2g. So we are getting a curve because of this formula, whether you are using displacement or vertical height in terms of time, or you are using vertical height in terms of velocity. It's not a linear equation. The reason for which the displacement is a curve. So it also means that as at t is equal to 0, this is t against s. As at t is equal to 0, displacement is 0. As time increases, a displacement will also be increasing. It will also be increasing. So we get to the maximum height or the total height it could travel. Okay, so instead of h, let's use h. So this is the displacement time graph for free falling body. This is the velocity time graph for free falling body. And this is the velocity is a straight line because here v is equal to gt. Either v is equal to gt or v is equal to square root of 2gh. This is a straight line. It isn't like this. The reason for which velocity time graph is straight line and then this is a curve. Please, I did this to let you understand that the displacement increases with time. Josiah, mute yourself for me. So this is the velocity time, but this is a body falling vertically downwards. Then its acceleration time graph. It is falling due to gravity. And the body accelerates at a constant value due to gravity. So if we are to plot the acceleration time graph, a graph of acceleration against time has this constant value. This is plus g. Because it accelerates, it's a plus g. The acceleration is constant. So this is the acceleration time graph for a free falling body. Please, any question? If you have any clarification to seek. All right, then let's look at when the body is thrown vertically upwards. This is vertically downwards. So Josiah stands on the floor or on the ground, throws an object. What will be its trajectory? What will be its velocity time graph, displacement time graph, and then acceleration time graph? Somebody hasn't muted, and I'm getting the feedback. Aqua Leonard. Leonard, mute yourself if you don't have question to ask. Oh, Nuya. Nuya, please mute yourself. Or you don't speak until you want to speak. Okay, so when the body is thrown vertically upwards for vertically upwards motion. So over here, Leonard is on the ground. He is throwing a body up. Of course, for the body to go up, there must be an initial velocity u. So the trajectory, which is the path or trajectory of the body or of the object is this. The body takes off, would go get to a maximum height and then return. So it will go and then return. As for vertically upwards, when it is thrown, it won't suspend in the air. It will surely come back. Unlike downward motion, where the object will just drop on the ground and then rest. Over here, when it gets to the maximum height, the body must return. The body must return back to the ground. And so this is the path taken by the object. Please, are we okay? Hello, are we okay?
Yes, please.
The velocity time graph and the displacement time graph. Then the acceleration time graph.
It's too late to turn back. You have to keep going. Otoyasu, I want to talk. We're not here to start a fight with you. All we're asking is that you let us through.
So when the body is thrown vertically upwards, a part is that for the displacement time graph, I'm coming. Crispin. Let me mute all, okay? All right, so its part is that, you see, the body would go up, cover some height, get to the maximum height, and then will return. So the displacement time graph displacement or height time graph. Don't forget the height. We are determining the height from the relation if it's going up. H is equal to UT minus half GT squared. This isn't a linear one. If it is coming down, because U is 0, we equally use half GT squared. And because of the relation, we'll get a curve, just as we saw, we saw it for when the object was thrown vertically downwards. So when the object is thrown up, its height would increase, then get to a certain maximum height. Get to a certain maximum height, and then from there would return. As it returns, its height would increase before it drops to the ground. So this is how the displacement time graph of a body thrown vertically upwards will look like. So you realize that the body's displacement increases with time. At time t is equal to 0, displacement 0. Well, at time t is this, it would increase. Then it will get to a certain maximum height. At the maximum height, H max, V is 0. Then the object would return to the ground again. But because of how the equation for the displacement is, the reason for which is not a straight line, but a curve. Now, velocity time graph. This is its velocity time graph. The body begins with, it is being projected vertically upwards. So the initial velocity must be greater, so that as the body goes up, what happens to the velocity? As the body goes up, what happens to the velocity?
Decreases.
Yes. Come again.
Decreases.
It decreases with time. So it must start with a higher velocity. Over here, velocity is 0. When we are going up, it is increasing. But over here, before the body goes up, it's going up with a maximum velocity, so that as it goes up, on and on, its velocity decreases, and at the maximum height, decrease to 0. So it must begin with a higher value, then decreases with time. Now, when it gets to the maximum height, at that point, V is 0, and velocity is 0 as soon as the line touches the time axis. So, at this point, it means we are talking about the time t is equal to u over g. This is the time we call as the time taken to reach the maximum height. So the body has gotten to the maximum height. Now it has to also move from the maximum height and then drop back to the ground. So the velocity is 0 at the maximum height. When it is coming from the maximum height, please, what happens to the velocity as it drops to the ground? Hello, when it is returning from the maximum height, what happens to the velocity?
It increases.
It
It
increases.
increases. So when it's going up, it is decelerating due to gravity. When it's coming down in the opposite direction, it is acceleration due to gravity. So the velocity would increase in the opposite direction. 0, then increase up to a point where its velocity is twice. So at this time, the time to this point, okay, is that where we have t is equal to 2 times u over g. At this point, the velocity is twice, okay, the time taken to reach the maximum height. So the body is moving from here to the maximum height. The time taken to reach the maximum height is u over g. It will take the same time to get to the ground again. So when it's here, its total time, capital T, is equal to 2 times u over g. And that is what has been indicated here. So this is the velocity time graph for a body thrown, getting to the maximum height, and then falling back to the ground. At this time, V is 0, and this is the time taken to reach the maximum height, which is equal to u over g. Then, from the maximum height, its velocity will be increasing again. So, a drop in velocity in one direction, and then an increase in velocity in the opposite direction. So, this is the velocity time graph. Please, are we okay? Any question? So that is what I gave you. That's the question I gave you. Now the acceleration time graph. The acceleration time graph for this will be, when it is going up, it is decelerating. So minus g. This is AT. Acceleration time graph. When it is going up, it is decelerating. So constant. And when it is coming down, it is accelerating plus g. But what's at Mhm. Please come with your question again. It is gone. Let me get that clear again. Cadmiel, come again if it's you. Or you ask. Please, if you have any question, ask before. Also, when the line goes past the time axis, what is that portion called? Okay, so when the line goes, the moment the line touches this, it means we are at the maximum height where velocity is 0. So at this point, V is 0. So it means we have reached the maximum height. And the time taken to do that is U over G. Now, when the line goes past the time axis, it means that the body is returning back to the ground. The body is returning back to the ground and its velocity is increasing in the opposite direction. Please, this is the reason why this graph is drawn over the positive V and then the negative V. Okay. The graph is drawn over positive V, which is here, and then negative, meaning that as we go in one direction, the velocity will be decreasing. In the opposite direction, the velocity will be increasing. So as we go, our velocity will be decreasing. As we come down, velocity will be increasing. So we have two different directions. The reason for which we have this and this. So going past the time axis means that the body is returning back to the ground. Please, are you okay? All right. All right. So let me give you a question. We are going to try our hands. I'm going to drop the question on the platform. I'm coming. I'll upload. All right. So I've sent a question to the platform. Please go through it for me. The question says that a ball is thrown vertically upward from the ground with a velocity of 80 meters per second. A ball is thrown vertically upward from the ground with a velocity of 80 meters per second. On its return, the ball lands on top of a building with a velocity of 60 meters per second. How high is the building? Take G to be equal to 10 meters per second squared. Okay. Let me take the question again. A ball is thrown vertically upward from the ground with a velocity of 80 meters per second. On its return, the ball lands on top of a building with a velocity of 60 meters per second. How high is the building? Take G to be equal to 10 meters per second squared. Please go through it for about 2 minutes whilst I clean the board. All right, so let's extract. A ball is thrown vertically upward, so it is actually going up from the ground with a velocity of 80 meters per second. So let me change the marker. U is actually 80 meters per second because we all understand when it is thrown vertically up without any force or initial velocity given to it, it can't actually go up. So it will need initial velocity U. And this we are given as 80 meters per second. On its return, when it go to the maximum height and then returning back to the ground, the ball lands on top of a building with a velocity of 60 meters per second. So the path is like this. This is the ground. The ball is thrown, gets to the maximum height, and on its return, it lands on top of a building. And it lands on the building with a velocity of, as at when the ball lands on the building, the velocity is 60 meters per second. Then we are to calculate for h. We are to determine h. How do we calculate the height of the building? I want you to help me determine the maximum height reached. Help me calculate for the maximum height h max. When the ball is thrown with this velocity, what will be the maximum height reached? The maximum possible height reached.
U
Yes.
square over 2G.
So U squared over 2G. Thank you. So we have 80 squared divided by 20. Okay. So what is 80 squared divided by 20? Uh-huh. 320 meters. Okay, let's have somebody else to confirm. 80 by 80 over 20. This and this. 2 goes here, 4. 4 by 8. 32. So 320. Thank you. So the maximum height is, now when the ball gets to the maximum height and it is returning, what's the velocity there? At the maximum height, what's the initial velocity? How's at the maximum? Pardon? Come again. At the maximum height, what is the initial velocity there? Oh,
Zero. Zero.
0, because it is free falling. When it gets to the maximum height and it is coming back, it is free falling. So the velocity is 0. So if we have u0, and that's at when it hits on the floor, final velocity is 60. Can you use that to help me determine the height of the building? Help me determine the height of the building. Knowing u and v, you can find this distance. You can find this distance. Knowing u and v, you can find this distance. So when you determine this distance, we can easily find the height of the building. So I'm giving you 3 minutes. Engage your books. Let's see what you can do. We have u and v, and acceleration due to gravity is constant. Okay, so we have u and v. Let's determine this height so we can find the height of the building. Or in other words, let me use h for this unknown height the body will cover before it lands on the building. So that when we find h, we can easily find the height of the building. Please, is that okay?
Yes.
So 4 minutes. Let me add 1 minute more. 4 minutes. Make me proud. Let me check on attendance and then okay, so if initial velocity is 0 and just when the body hits on the roof, say it with me, 140. Okay, just when the body hits on the roof, it is hitting the roof with a velocity of 60. Then when I use v squared is equal to u squared plus 2jh, I must find h. So h therefore would be equal to v squared. This is 0. So v squared over 2j, because u is 0. So 60 squared over 20. And this is 60 times 60 over 20. And this would be equal to 180 meters. If h is 180 meters, Eva, what is the height of the building? Eva. Eva. The height of the building would be, yes, Eva, I'm listening. Hey, Eva is quiet too. Angel, just bring your angle. Angel, bring your angle. What will be the height of the building? If I talk to me, you won't talk. And you are playing music at the background. Okay, so we have the whole from the ground to the maximum height is 320. So if this is 180, then we have 320 Okay, 320 minus 180. And that is equal to, what is 320 minus 180?
140. 140.
140.
It's 240.
140.
So that's the height of the
It's
building.
100.
Did you say 140? Oh, yes, 140. Thank you.
Please.
Yes, please.
That's the height of the building. Is it difficult? Is it
No,
difficult? Let me post another one for you to attempt. This one, you will do it for some time before I also come in. And I've sent that to your platform. So please check on the platform. Listen, I've equally sent it to you.
Thank you, sir.
So I'll give you together. At least you can use the discussion to just look at what you have done. So two particles, P and Q, are each positioned at a height of 100 meters above the ground. So you see, these questions, to answer it very well, you need to be drawing. If you don't draw, you won't, understand how to go about the question. So we have the ground here. Hold on, let me change my markers. And we are told that we have two particles, particle P and particle Q. From where they are, from where both particles are to the ground, the distance is 100 meters. So both of them are positioned at a height of 100 meters above the ground. P is projected vertically upwards. So we are throwing up P, that is going up. And then with a speed of 10 meters per second. So it's before it goes up, it has to be given an initial speed, 10 meters per second. While Q is projected vertically downward with the same speed. So this time it is not just free falling. This is being projected downward with the same speed. 10 meters per second. Calculate the time interval between the arrival of P and Q on the ground if gravity is given as 9.8 meters per second squared. So that's the question. So we must pick each of the particles one after the other and then analyze. So for P, I think Q is easier, so let's start with for particle Q. We are given the initial speed. We have the height. So H is equal to UT plus half JT squared. So to determine the time taken for Q to move from this point to the ground, H is 100, U is 10, T is what we are looking for, plus half by 9.8 times T squared. Please, are we there? Hello, are we there?
Yes, sir.
Yes, sir.
Okay, so let's simplify this. 10T plus 9.8 divided by 2.
Please, 4.9.
4.9.
So 4.9 T squared. This is 100. So we have a kind of quadratic equation. When we equate everything to 0, we have 4.9 T squared plus 10T minus 100 is equal to 0. Meaning when we let this cross the equal to sign, okay, we have a way of solving this, and I'll take you through. When we divide through by 4.9, of course, 0 divided by 4.9 is 0. So we have T squared plus, divide 10 by 4.9 for me. It was something greater than 2. 10 divided
2.048.
2.0
408.
2.40.
2.0408.
Okay, 0408. Okay, so T minus 100 divided by 4.9.
20.4081.
20.4081. So 1. I'm approximating it. So now when we compare this to a general quadratic equation formula, which is ax squared plus bx plus c is equal to 0, we realize that a is equal to 1, meaning x squared is t squared, x is t, and c is this. So a is equal to 1, b is equal to 2.041, and c is equal to minus 20.41. So let's use almighty quadratic equation formula to solve for t. This is the almighty quadratic equation form. When you are looking for x, x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Leonard, mute yourself. Leonard, mute yourself. Now, over here, the variable we are looking for is t. Our unknown variable we are looking for is t. So we create this formula, almighty formula. Mamiya,
Please, I'm lost. I don't really get it.
Where?
From the A, B, and C, please.
You see, if you have a quadratic equation, how to solve for the quadratic equation is by the use of this. So what I've given you is the general quadratic equation formula. And a quadratic equation is any equation with the highest power of 2. Okay, so this is the quadratic equation formula. And whenever you have this and you are solving it, one of the approaches in solving it has to do with this formula I've given you. And this is the quadratic equation formula. This is known as the quadratic equation formula. So we are using the equation formula. We are using that to solve this quadratic equation we have here. T squared plus 2.041t minus 20.41t. 20.41 is equal to 0. Of course, this is similar to the general formula. So, Mamiya, that is what we are doing. We are using the quadratic equation formula to solve this quadratic equation to find t. Please, are you okay?
Yes, please.
All right. So that is why I compared what we have. This is what we have to the general formula, and then determine the coefficient A, B by comparing A, B, and C. So after getting A, B, and C, you come and substitute it into this formula, which I have here. So it means T, my unknown is T. T is equal to, what is B? B is 2.041. So minus 2.041 plus or minus square root of, with under the root sign, we have B squared, the same B, but this time squared. So 2.041 squared minus 4 times A. What is A? A is 1. What is C? C is minus 20.41. So since A is 1, I won't bother myself with it, but I'll just use it for C. Minus 20.41. All divided by 2A. But A is 1, so divide by 2. What is left is the use of calculator. Please, what is, square this 2.041 squared plus multiply 4 by 20.41 and then give me the results. Of course, it must be positive because this will be positive, negative and negative positive. Then this is also positive, but please, this is squared. So simplify this for me. What is 2.41 squared? I'm waiting for you to simplify what is within the bracket for me. Yes, who is true? Angel, Eva, Paulette. Let's manage time, please. So what is, I think, this is plus.
4 points.
I'm coming. Okay. So when you squared this, what did you get? 2.041 squared.
4.166.
4.166.
Okay. So this all divided by 2. Now sum this up and then find the square root of that for me, the results. So square root of 85.806. The guys, what are you doing? Jojo and Co.
That is 9.263.
9 point.
9.26.
Okay. Now look at something. What we have here is plus or minus. The time cannot be minus. Okay, time cannot be minus. So we'll ignore the minus and go with the plus. So we have 9.266 minus 2.041, all divided by 2. Please quickly do that for me. 9.266 minus 2.041. We have 7, Gabriel, we have 7.225.
That is it was plus or minus. So
Yeah.
why didn't we separate why didn't we separate the fraction? Then solve for plus and minus, then ignore it.
No, this is how we do it. This is how we do it. Let me take you through and then let you understand why I ignored it. Ideally, this is minus 2.041 plus or minus, is that 9? You have 9 point what? 266.
26.
It's 9.26.
26. Okay. Divided by 2. So ideally, this is how we do it. Either T is equal to minus 2.041 plus 9.26 all divided by 2, or minus 2.041 minus 9.26 all divided by 2. Gabriel, are you okay? Are you there?
Yes, sir.
But what I'm saying is that if you pick this one, this will give you a negative time. But we don't have anything like negative time. So we throw out the negative and concentrate on the positive. You get it?
Okay. Yes, sir.
The reason for which when we got here, I just cleared the negative and maintained the positive. Are you okay?
Yes, sir.
All right. So we more or less have 9.26 minus 2.041 all divided by 2. And when we subtracted, we have 7. Okay, let's go through again. 9.26 minus 2.041. This is 7.219 divided by 2. So when we divide our numerator by 2, we have 3.6095 seconds. What it means is that for Q, it will take it this time to land on the ground. So we have the time for kill, T kill. Physics will open your mathematical ears as well. So it's good we are also doing this. Okay, so this is it for T kill. The time taken for kill to land on the floor. We have to look at it for P. So please, if you are not done writing, quickly do it. And then because I'm going to clear the board and go through it for P. And do not be frightened. Okay, you master. It's a gradual thing. Okay, so go through it gradually. If you didn't know something, now you know. You learn from it and then work on and on, and your math will be good, and so your physics would also be better. So do not be trampled that we are doing quite a lengthy thing. Can I clean it?
No, please.
All right, so hurry up for me. Please let me know when you finish, okay?
So this is what I was supposed to do.
Can I clean it?
No, please.
Leonard, so you are lost. Oh, don't be lost. We just finished solving the time taking for kill to drop on the ground. We are here to look at the time taking for P to land on the ground. Okay, so we are doing a gradual thing, systematic. Get the time for P, get the time for kill. Then when we finish, we find the time interval or the difference between when kill landed and when P landed. That is the demand of the question. But because it's quite a lengthy approach, the reason for which we are doing that systematically. Leonard, are you okay? So relax. When we finish, please, you can spend time to review the video. Spend time to review the video for me. Hey, those of you writing, please, let's hurry up. I'll be giving you but Leonard, I'll give you the video too. You want snapshot. Okay, so under the request of Leonard, I've dropped a snapshot to the group. I'm dropping the second part as well. So okay, so you have the shot of it on the platform. So pick it from there so we could continue. Okay, so we are going to look at it for P. I think P will be easier. P would be easier. And for Q, we use quadratic equation because the equation is not simple to solve. So whenever you have a quadratic equation and it isn't simple, your redeemer, your redeemer is almighty quadratic equation. So that would surely redeem you. Okay, so let's look at it for P. And P, look at what happens for P. P will move from here, okay, the same level as Q, but because P was initially thrown vertically upwards, it will go up, reach the maximum height, and then drop to the ground. So this will be the trajectory or the path of P. It is thrown vertically upwards, whereas Q was thrown vertically downwards. So P would go up, reach the maximum height, and then return to the ground. So for particle P, we need to determine the time taken to reach the maximum height, T1. And the time taken to reach the maximum height for vertically upward motion is U over G. So this is 10 over 10, which is 1 meter, 1 second. Please, are you okay here? Are we okay here? Hello.
Hi.
Are you okay with this part? So
You
it
were
would-
giving G
Yes.
9.8.
9.8.
Oh, okay. Thank you. You see, that's why you need to talk. 9.8. So what is, that will be something greater than 1. So 10 divided by 9.8, 1 point what? One point.
1.02.
Thank you. So the time taken for P to move from here, get to the maximum height. Now from the maximum height, it is free falling to the ground. So let's also determine the time taken for P to move from here and drop to the ground. Okay. But before that, we need to get the maximum height because we'll use that, add it to 100 to find the time. So help me determine the maximum height when P was projected from the 100-meter level. Help me determine H max. Yes. So H max will certainly be U squared over 2J. So 10 squared over 2 times 9.8. And this is equal to 100 divided by, or 50 divided by 9.8.
Zero 0.51.
Come again.
0.51.
0.51. Oh, I think that would be greater because you are talking about 50 divided by 9.8. Oh.
Please,
5.102.
5.102.
All right. So it means that this is the maximum height. So if you are looking for the time taken to move from the maximum height and drop to the ground, then using h is equal to ut plus half jt squared, we can find that h will be 100 plus this. So 105, 100 plus 5.10 plus 100, 105.102. When it is returning to the ground, it is free falling. U is 0. So this part goes to 0. So we have half times 9.8 times t squared. Help me calculate for t. So I'm waiting for you. So, yes, yeah. Yeah.
Please, how did you get the values to put that you inserted into the equation? The 105.102 and the
Okay.
half and everything.
Okay, so yeah, all that we are doing is that we want the time when the body P gets to the maximum height. It will fall from this height to the ground. Okay. This is already P and Q were positioned 100 meters above the ground. So this is 100 meters. 100. Meaning to determine the time taken to move from this point to the ground, I need to have this time at this height too, because I already have this. If I get this part, this unknown, and add it to this, I'll be able to find the total height from the maximum height to the ground. Yeah, are you okay?
Yes, please.
So I use maximum height to calculate from here to here, and that gave me 5.102 using u squared over 2g. Using u squared over 2g, I was able to find the maximum height. So 10 squared over 2 times 9.8. Yeah, are you okay up to this point?
Yes, please.
Good. Then, so knowing the maximum height, if I want the total height from the maximum height to the ground, it is 5.102 plus 100. So using h is equal to ut plus half jt squared, I can find this t because I know h. H is 100 plus 5.102, and that is the 105.102. Now, I know when it is falling from the maximum height towards the ground, it is free falling. If it is free falling, then the initial velocity u is 0. So 0 times t will still make this side go to 0. The reason for which this side never featured. Yeah, are you okay?
Yes, please.
Good. So
So please, okay.
go ahead. Yeah, go ahead.
No, I understand.
Okay, so all that I need, knowing H, having G, all that I need is T. And so I just simply made T squared the subject. And then I hope you are fine now.
Yes, please.
Okay. So T is equal to the square root of 21.449. And what's the square root of this? What's the square root of 21.449? Pardon?
Please 4.631.
5 points.
4.631.
Good. So look at what we've done. We found the time taken to move from here to here. We earlier calculated for the time taken to move from here and get to the maximum height. So total time for P, the time of flight of P, will therefore be equal to 1 plus 4.631, which is 5.631. Now, what is the time interval between P, the arrival of P, and Q on the ground? So therefore, time interval for the arrival of P and Q on the ground is, so 5.631 minus, what did we get for the time of Q?
3.6095.
So 3.6095. Please subtract it.
2.0215.
2.0215 seconds is the time interval between the arrival of P and Q on the ground. It isn't a difficult question, but you need to think through, and your math must also be a bit better. But please, Yasmin,
Please, can you shift your camera to the right a bit? I can't see what's on the board.
is it up or down?
Please down, but to the right.
I think it's the marker. Let me write it well here. But I'm sure you can see the 5.631.
Yes, please.
All right, so what I was writing was the conclusion that therefore time interval for the arrival of P and Q, okay, on the ground is. So I was concluding time interval for arrival of, because that was the question, of P and Q on the ground. So after having the time for P and Q, you just conclude 5.631 minus 3.6095. And the interval is 2.02, maybe 2 seconds. So Yasmin, this is what I have here. All right. Okay. Let me send you another question. This time you would do it and then send it to me. The same, similar. In fact, it's always good to try your hands on challenging questions. For me, I usually like it that way than giving you simple questions so that when you
So when
see,
you submit it,
let me send first, okay? Let me send first and then give you the time for submission. I've not been able to even locate my question, but I'm coming. So, particle P is first up. This time around, both particles are shot vertically up. Particle P is first up with a velocity 40 meters per second. After 4 seconds, particle Q is also shot up, meaning the time of P leads the time of Q by 4 seconds. So listen, after 4 seconds, particle Q is also shot up, implying that for time, P leads Q by 4 seconds. So if the time taken for P is T, the time taken for Q will be T minus 4. Take note. P leads Q by 4 seconds. I am starting. So two particles P and Q are shot vertically up. Particle P is first up with a velocity for 40 meters per second. After 4 seconds, particle Q is also shot up. Find A, where the two particles meet. If at the point of meeting, P has a velocity of 15 meters per second. So you are looking for where the two particles would meet. If at the point of meeting, particle P has a velocity of 15 meters per second. Then the B question, find the velocity with which Q is short. Find the velocity with which Q is short. Take gravity, acceleration due to gravity, to be 10 meters per second squared. So let me explain the question a little bit to you. We are two particles, P and Q, are shot vertically upward. They are all going up. But P was thrown first before Q. And we are looking for the point where the two particles would meet, cross. Okay. Now, if the throw was not delayed, there's no way they can cross each other. But because the time for the throw was delayed, then this can get to the maximum height, and when it is coming down, will cross the other one. Okay, so it can only be possible because the time for the throw was delayed for Q rather. So though they are all going up, but one was shot ahead of the other. So when one gets to the maximum height and it is returning, then it can cross Q. So we are looking for the point where both particles would cross each other, where they will be equal in terms of height. And then you later look for the initial velocity of Q. That's the whole question. So please, what I want you to do is that look at the two strong examples we've solved. The first one, this second one, and then think through. You can share ideas. You can call, okay, to share ideas, and then let's see what you can do. Okay. All right. In tomorrow, tomorrow, I think we will discuss this. But I want you to try your hands and then give me feedback before tomorrow, okay, to see what you were able to do. Then we discuss it.
Yes.
Michelle,
Sir, please, what time will we be meeting tomorrow?
it will certainly be from 4 to 6, either 4 to 6, or I'll push it maybe 6 to 8, or okay, so as to favor all of you. Okay.
Thank you.
But I'm hoping power will not be taken at that time. Leonard.
Yes.
Yes, Leonard.
I'm supposed to submit what is done on our private stages or
Oh yes,
to the
yes.
or to the person.
Just try and then send it through to me via your private WhatsApp groups. Okay. It isn't. I want you to give it a try. Okay. Just let me know what you are doing, and I'll be fine with it. So this is where I draw the curtain. Please visit the YouTube and then go and watch the video. Subscribe, share, and then like. Okay. So we'll have another session tomorrow. Until then, please take care of yourselves and may God be with you. Bye-bye. Oh, Yasmin, I talked about vectors. Yasmin, I made mention of it, vectors, right? Okay. Bye-bye.
Bye.
Bye.
Bye.